Hi everyone, welcome to the INTARCON webinar. Today we are going to present our new range of R290 propane monoblocks. Those are compact units for refrigeration and sustainable solution designed by and for installers. Today you will discover the new CR MPD and CV MPD models designed to simplify installation, improve energy efficiency, and adapt to current environmental requirements. So let's get started. First of all, here are the key issues we will attend today. First, environmental and regulatory drivers. We will look at how new regulations are impacting the sector, the market, the refrigeration market, and how INTARCON is anticipating these changes. Next, we will see the new R290 developments, such as INTERBLOCK Pro and INTERTOP Pro, and we will explore the features and benefits of this equipment. Next, we will see different case studies that are solutions for commercial refrigeration for a better market fit with this equipment. And next, finally, we will see practical examples with Client 360. That is the software platform for refrigeration projects that we use here in INTARCON, and we recommend to our stakeholders because of its 360 and holistic solution for refrigeration project management. Our journey towards a sustainable future starts in 1987 with Montreal Protocol, first major global step to protect the ozone layer by limiting CFC refrigerants. That was a key milestone in the environmental struggle. Next, in the Kyoto Protocol, we established mandatory targets for reducing greenhouse gases, although lack of global consensus slowed further this progress with this protocol. Next, in 2015, through the Paris Agreement, marks the year where the world agreed ambitious targets on energy efficiency. And the key one was to get lower the temperature rise below the 2 degrees. That was the target. That through the Kigali Amendment, that is an amendment to the Montreal Protocol, we focused on reducing the HVCs to maintaining this global temperature rise to below these 2 degrees. Nowadays, for example, the current regulation that we have here in Spain, we have to comply are the RCIF, that it defines the safety requirements for flammable refrigerants such as R290. Other current regulation is the EN 378 that limits the maximum charge, for example, in cooled rooms that are smaller than 20 meters cubic. We have got a limit of propane that is 150 grams in this volume. For higher chairs, the minimum volume is adjusted according to the safety limits, flammable and toxic. And finally, we can see the F-gas in 2024 that make restriction on refrigerants with high GWP, promoting the transition to natural refrigerants. As you can see in this graph, the reduction in the quota of fluorinated gases is a direct result of the international environment agreements mentioned above. Europe, with the will to lead the sustainable transition, introduced in 2014 the F-gas regulation to regulate and limit the marketing of refrigerant with high GWP. However, it was not until 2018 that this reduction had a real impact on the European market. This year was a pinch point that when we reduced the supply and we increased the demand for supply, led to an exponential increase in the price of HFCs. This scenario accelerated the search for more sustainable alternatives, such as natural refrigerants, such as CO2 or NH3, or propane in this case. So, along the graph, we are here today in 2024, and we have to comply the F-gas and their limits. On the other hand, we have got developing countries such as Group 1, that this process will start most visibly in 2028. Even by 2034, the quota will have fallen 20%, and they will have similar situation that we lived in the past. So the future of refrigerant lies in a low refrigerant short solution and the use of natural refrigerants, such as we said before. So anticipating this change is not just an opportunity, it's a necessity to ensure sustainability and competitiveness in the market. The challenge for compact equipment from 2025, where Europe will ban the market of compact equipment using refrigerant with high GWP above 150. So what does this mean for the market? Traditional refrigerants with high GWP will no longer be viable, and this will force the industry to look for sustainable alternatives aligned with environmental regulation. At INTARCON, we are anticipating these changes by opting for solutions with natural refrigerants, in particular, in this case, with propane. So let's see the new R290 development. Now we see the last monoblock equipment. Here you have the previous one, a design based on HFC refrigerants, which for years was the reference in the market. But change is unavoidable and progress is necessary. And at INTARCON, we have taken a step forward to the future. For Interblock Pro and Intertop Pro, we present our new development with R290, a renewed design that combines efficiency, sustainability, and adaptation to future regulation. These new developments are the Interblock Pro and Intertop Pro. Let's dive into Interblock Pro, that is designed, as I said before, by and for installers, introducing the new compact R290 monoblock, that is a solution for small and medium-sized refrigeration, preservation, cool rooms. And let's see the main key features. That is a 100% natural solution. We use R290 as refrigerant with low GWP. A practical design, that is a wall mounted on the wall in the room, facilitating the installation. We use a double refrigerant circuit in higher capacity models. We use a compressor per circuit. for more robust and reliable operation. Next, we can see the quality components. We use a cubic aluminum evaporator, a thermostatic valve, and hot gas defrost for remove the defrost in the evaporator. This equipment is also available in 50 years with 230 volts and 400 volts as option. Finally, these all equipment are tested in the factory to guarantee an optimum performance in each unit. These are the main specifications for the Interblock Pro. First of all, we have got exchangers with protection, evaporator. We have got a copper tube and aluminum thin coil with cataphoresis treatment for greater durability. In addition, the condenser has a microchannel with polyester paint coil that guarantees resistance to corrosion. We see the numbers here in the photo. The number 2 is about the electronic fans that we use in the condensing. We modulate the speed control on the condenser to optimize the energy consumption, and we reduce noise in addition. Next, the washable air filter that is designed to prevent fouling and dust introducing in the condenser and for facilitating the cleaning too. We can see here. Next, the removable evaporator front register that could be opened with a front access to fans and access for the condensate tray for cleaning them. That is the best solution for units that are situated between shelves, for example. We use a hot gas defrosting. It's a system where we use a liquid line that closes when we activate the defrosting mode, allowing us to remove quickly the defrost and keep us also to return to the operation very fast. Next, the control panel here. It's a front access integrating all the protection and electronic control elements with terminal block for connection. The tampon that we use here in the CV model in 2 different ways for medium temperature and low temperature. That depending on the application, we will use 100 millimeters or 150 millimeters. The condensate tray that is made of stainless steel is removable and accessible from the outdoor unit. And finally, quick connectors for all the components in the equipment: probes, fans, pressures, switch, every component. In addition, we have options available to suit every need that the installer has. With this option, our Interblock Pro adapts to any specific environment and needs. Let's see some examples, such as a radial fan with vertical discharge, easy electronic, that is recommended for the discharge of condenser air to the outside to avoid the temperature increase in the outside of the condenser. Next, the adaptation to a double heater for units that are suited for low temperature and medium temperature too. The option for water condensing for an inlet range from 5 degrees up to 50 degrees. That is recommended in the installation of a water loop system. Or even we could work in a range from minus 10 degrees up to 5 degrees, only for low temperature models, when we use a chiller system. In addition, we recommend a water solenoid valve for installation outside the unit if we want effective defrosting in units above 1:1. One evaporator, one condenser. Other options, such as adaptation to the equipment for outdoor installation, we change the chassis for adapt to the environment, for an aggressive environment, allowing free wire for the electrical supply, Chugo type for this electrical supply too, for this connection. And in single phase and three-phase model, we have got voltage, phase voltage monitoring and voltage and phase failure in each cases. Furthermore, as we said before, 100 or 150 millimeters tampon thickness, if this is the case. And lastly, a drainage resistor for avoid the freezing in drains. Okay, in the part of electronic controller, we use the XMC670K. That is a multifunction digital remote control, which have got temperature control with recording the maximum and minimum temperature in the cool room, and the possibility of interconnection and synchronization of up to 8 units in a LAN network. In addition, for CB-MPD access models, we have accessories that are supplied separately for better installation, such as hopper for installation to circuit duct, tampons, and non-return gate and doors microswitch too. If we see the installation scheme, we use a wall mounting, simple and efficient installation that are designed for wall mounting system in the cool room. This is a practical solution and is specifically designed to optimize space and reduce time. In the case we use the vertical radial version, interblock units with radial fans has available static pressure of 100 pascals for the conduction of hot air to the outside. Here we can see the modules for medium temperature, and we use chassis from 1 up to 3 using one circuit for equipment that has got lower cooling capacity, and 2 circuits, one compressor, one reciprocating compressor for each circuit for upper cooling capacity. We've got a cooling capacity range for a cool room temperature of 0 degrees from 600 watts up to 4.2 kilowatts. And using a low charge of refrigerant that is lower of 150 grains. For low temperature models, we use chassis from 1 to 3, circuits, 1 or 2 circuits, one compressor per circuit, and we've got a cooling capacity range for a cool room of 20 degrees from 600 watts up to 2.2 kilowatts. In addition, we see that the refrigerant charge is lower than 150 grains, but units that that got one single circuit got more lower charge of refrigerant, but it's less than 300. Here we see the dimension of the equipment for any chassis and the dimension of the mounting frame of the equipment. We could see this folder, this commercial folder, after 2025, after January. Let's see some renders of this equipment. This is a design optimized for performance and maintenance. Fans that are AC in the evaporators and EC in the condenser. The condenser coil protection that we said before. Cataphoresis in evaporators and polyester in condenser coil. Here we can see the panel thickness for this model in this case. The air filter, also here in the condenser part. Of course, the aluminum cubic that would be inside the cooled room. This will be the part of the condenser tray. The fans of the condenser EC. And for example, it has got an easy and quick disassembly and replacement of components of the coils because of it is screwed. Finally, these renders, we can see an easy access and an easy assembly adapt to every need that allow us a rapid intervention in the equipment. So we can see this, for example, in this case, once we retired the front chassis of the condenser, we see how we have got space to work and operate inside it. So now let's see the brother of the Interblock Pro, that is the Intertop Pro. We use here also features that are similar to the Interblock Pro. First of all, this equipment is also designed by and for installers, and the key features are similar to the equipment we watched before. It's a natural solution with R290 refrigerant. It's a plug-and-play system. It's available with 200, 330 volts and 400 volts with 50 Hz as a frequency. We use also a double refrigeration circuit in higher capacity models, using one compressor per circuit, using also quality components such as a thermostatic valve, washable air filter, or even the hot gas defrost we used also before in the last equipment. And of course, every equipment is tested in factory. So let's see the main technical specifications, such as exchanger with protection. In the evaporator, we've got a copper tube and aluminum film coil with cataphoresis treatment also. In the part of the condenser, we've got a microchannel coil that is painted with polyester to guarantee the resistance to corrosion. Next, we see the electronic fans that we use in the part of the condenser, a washable air filter to the entry of the new air in the part of the condenser. We use a hot gas defrosting. We see the next in the number 6, the control panel. We've got the protection and the unit control here. I've got very good access and easy. The part of the tampon that we use here, this is different from the interblock. We use here 18 millimeters thick, and it is injected by polyurethane foam and covered in aluminum. That will be this part, the number 7. And is divided into 2 main parts for quick access to the evaporator, and is sailing with only 3 screws. We've got also the condenser tray made of stainless steel and quick connectors for each component. In options, we have got options that are very similar, such as radial fan. In the interblock, we use a vertical discharge. Here is radial discharge with the same recommendation. Adaptation to a double heater in low temperature equipment. The possibility of condensing in water from a range from 5 degrees up to 50 degrees in a water loop system, or minus 10 degrees up to 5 degrees in a chiller system if it is the case. Always we recommend the water solenoid valve for installation outside the unit for effective defrosting in units above system 1:1. Halogen-free wires and Shuko type in power supply. Voltage monitoring in single phase model, and even voltage and phase failure monitoring on 3-phase model. Drainage resistor, and here we have got a new option that is box for external air inlet duct, adjust for outlet shapes. The controller is the same, the XM670K with the same specification, and here we have got new accessories for this equipment that are supplied separately for better installation, that are the air conduction kits. Okay, those are the same as we watched before. Next, the installation. The part of installation is so much different from the Interblock Pro. In the technical instruction, we could see all the path to install the equipment. To know more about it, I recommend to watch it. But basically, could be 3 steps. That could be preparing the hole in the ceiling, a suitable hole for the fans, mounting the fans these fans are suited and positioned from the inside of the cool room. They are first we assemble the evaporator fans, and next we assemble the unit, the compact unit, condenser and evaporator, once we have assembled the fans. This mounting system optimizes the installation because you save too much time in the installation with these steps. In vertical version, we've got also an available static pressure of 100 pascals for the conduction to the outside hot discharge air. For medium temperature models, let's see, we've got from chassis 1 up to 3, 1 circuit or 2 circuits, depends on the cooling capacity of the equipment. And we've got a cooling capacity range from 700 watts up to 4.2 kilowatts. Always with a low charge of refrigerant. In low temperature models, we see here the chassis 1 up to chassis 3. We use 1 circuit or 2 circuits if it is the case, and a cooling capacity range for a cool room of minus 20 degrees from 500 watts up to 2.2 kilowatts. The dimensions we could be in the brochure, in the commercial brochure. For example, we see here the mounting frame, the dimension we would need to install the evaporator fans. And let's see some images. We see we could use axial or centrifugal fan, or even a water-cooled condenser version. We see here the copper coil of the evaporator, an aluminum film that is cut with a cataphoresis treatment, and the use of 2 independent circuits. For example, these are the solenoid valve, the liquid solenoid valves, and the condenser tray, for example. This could be the control panel, the washable air filter, or the microchannel coil in the condenser part. Our monoblock equipment are present in international reference projects, offering efficiency, sustainability, and an ease of installation for the installers. And let's see some cases, such as Dani Garcia Group here in Spain, that is an application for cuisine, catering, and hotel sector, or even Amarande Hotel in Cyprus, that is a commercial refrigeration in the hotel sector. With this equipment, we comply with European standards, and we can adapt the equipment for the installation in small spaces. Finally, a practical example with Client 360 that will be available in 2025. We remain committed. We continuously are growing up this project, Client 360, and in the beginning of the next year, this equipment will be available for know more about this equipment in different operation conditions. So thank you so much for your attention. I will try to respond all the questions that you have. And if not the case, I will try to respond next. So let's see. I believe today there are no comments. Yesterday in the Spanish version webinar, we've got several. So if you want to contact with INTARCON, you could contact with our commercial partners. So thank you so much for attending this presentation, this webinar today. Let's see you in next video. See you.